Welcome, and let the world grow quiet around you. As you settle in, and let your breathing slow down all on its own, imagine drifting gently outward from the Earth, past the Moon, and far out into the deep and peaceful dark, beginning a calm and unhurried tour of 100 quiet facts about neutron stars. This is not a tour designed to frighten or excite, but a gentle invitation to wonder, and to drift softly towards sleep. There is nothing at all you need to remember tonight. Just let the words wash over you, one slow and quiet fact at a time, as you sink a little deeper into rest. The first fact is that a neutron star is the collapsed core left behind when a massive star dies, one of the densest objects that can exist without ever tipping over into becoming a black hole, a tiny sphere of almost pure neutrons, holding more mass than our own sun packed silently within a quiet space no wider than a single sleeping city, held together by nothing at all but its own crushing gravity. The second fact is that neutron stars are born only from the largest stars, those perhaps 8 to 20 times heavier than the sun, stars that live fast and burn bright and briefly before they finally run out of fuel, and can no longer hold themselves up against the endless, patient, and unrelenting inward pull of their own enormous gravity, until at last the core quietly gives way. The third fact is that when such a giant star exhausts its fuel, its core collapses in less than a single second, falling inward faster and faster, until protons and electrons are pressed together so very tightly that they simply merge into one another, and become the sea of neutrons that gives the strange new star its quiet name. The fourth fact is that as the core collapses inward, the outer layers of the dying star rebound and are blown gently away in a brilliant explosion called a supernova, which for a short while can outshine an entire galaxy of 100 billion ordinary stars, before slowly and softly fading back into the surrounding dark once again, leaving only the small, dense core behind. The fifth fact is that the collapse is halted, quite suddenly, by a strange quantum rule that forbids neutrons from being squeezed too closely together into the very same state, a gentle stubbornness of nature called degeneracy pressure, which holds the whole star up against gravity and keeps it from falling any further down into the endless dark. The sixth fact is that a neutron star measures only about 20 kilometers across, small enough to rest quietly within the space of a single sleeping town, and yet it carries within that tiny, silent sphere more matter than the entire sun, all of it folded down into an almost unimaginable and deeply peaceful density, still and silent in the endless dark. The seventh fact is that the idea of the neutron star was first imagined in the year 1934, only 2 years after the neutron itself was discovered, by two thoughtful astronomers named Botta and Zwicky, who gently proposed that a supernova might leave behind a small, dense star made almost entirely of these newly found particles. The eighth fact is that for more than 30 quiet years, neutron stars remained only an idea written on paper, a strange and beautiful possibility that many careful astronomers doubted could ever truly be found. So very small and so faint did such a distant object seem against the vast and silent darkness between the stars, far beyond the reach of the telescopes of that time. The ninth fact is that when a massive star collapses, the newborn neutron star inherits all of the spin of that enormous core, and just as a skater draws in her arms and turns faster and faster, the shrinking core spins up dramatically, until the young neutron star may turn many times over in a single second. The 10th fact is that a newborn neutron star is astonishingly hot, glowing at a temperature of perhaps 1,000,000 degrees or more, far, far hotter even than the bright surface of our own sun, though it slowly cools over the long ages that follow, fading very gently and very gradually into the surrounding cold and quiet, growing calmer and dimmer with every passing age. The 11th fact is that neutron stars are among the 3 possible endings for a star's long and patient life. The smallest stars fade into quiet white dwarfs, the very largest collapse entirely into black holes, and those that fall in between are left, in the delicate balance, as these small and dense and endlessly turning neutron stars. The 12th fact is that if a collapsing core is heavier than roughly 2 or 3 times the mass of our Sun, then not even the stubborn pressure of the neutrons can hold it up any longer, and it will continue to fall inward without any end at all, until it becomes, instead, a silent black hole vanishing quietly from the sight of the stars. The 13th fact is that this gentle limit, the greatest mass a neutron star can hold before collapsing further into darkness, is called the Tolman-Oppenheimer-Fokoff limit, and finding its exact value remains one of the quiet, open, and gently unanswered questions that astronomers all around the world are still patiently working to resolve even now. The 14th fact is that the gravity at the surface of a neutron star is staggering, perhaps 100 billion times stronger than the gentle pull you feel here on the Earth, so overwhelmingly strong that a single teaspoon of its matter, if ever brought here, would weigh about as much as an entire mountain range, so tightly is all of its matter packed together. The 15th fact is that because their gravity is so immense and so even, neutron stars are very nearly perfect spheres, smoothed almost flawlessly round by their own tremendous pull, so that even their very tallest mountains may rise only a few small millimeters above the surface, the smoothest and gentlest hills in all the universe. The 16th fact is that a neutron star holds the crushed remnant of a star that once shone brightly for millions upon millions of years, and in that sense it is a kind of quiet grave marker, a small and dense and enduring memorial resting silently in the dark where a great star used to be, a quiet echo of a light that once was. The 17th fact is that our own Milky Way galaxy is thought to hold perhaps 100 million neutron stars or more, scattered quietly throughout its long spiral arms, most of them long since cooled and grown faint, turning slowly and entirely unseen in the deep silence that lies between the more familiar and brighter stars. The 18th fact is that the nearest known neutron star lies only about 400 light-years away from the Earth, drifting peacefully along through space in a way that poses no danger at all to our small world. A tiny and dense traveler crossing the quiet dark, wholly and gently unaware that we are watching it, indifferent and calm as it drifts along. The 19th fact is that although a neutron star is unimaginably dense, it does no harm at all to anything far away from it, and its gravity, felt from a comfortable and gentle distance, behaves exactly like that of any other ordinary star of the very same mass, calm and steady and predictable and perfectly still. The 20th fact is that every single neutron star is a natural laboratory of the most extreme physics imaginable, holding matter under pressures and densities that we could never once hope to make here on the Earth, and simply by watching them patiently from afar, we quietly learn things no experiment on our own world could ever teach us, reading from the sky what we cannot learn below. The 21st fact is that the density inside a neutron star is almost entirely beyond imagining. A single small sugar cube of its matter would weigh about 1 billion tons, as much as a great and ancient mountain range, all of it pressed silently into a little space you could hold gently between 2 of your fingertips. The 22nd fact is that this is roughly the same density as the tiny nucleus at the very heart of an atom, and so a neutron star is, in a certain sense, like one single enormous atomic nucleus, fully 20 kilometers wide, quietly holding the entire mass of a whole star within its calm and silent bounds, one vast nucleus turning slowly in the dark. The 23rd fact is that a neutron star is not a simple ball of uniform matter, as you might first imagine, but instead has a rich, layered structure, rather like the Earth, with a very thin atmosphere, a solid outer crust, a denser inner crust, and a deep and mysterious core hidden far below. The 24th fact is that the atmosphere of a neutron star is only a few centimeters thick, a thin, hot shell of glowing plasma clinging tightly to the surface, and yet it gently shapes the light the star sends out, carrying quiet clues about the strange world beneath it across the long dark toward us, faint messages read patiently by our telescopes. The 25th fact is that beneath the atmosphere lies a solid crust, made of atomic nuclei packed into a crystal lattice far stronger and stiffer than any steel or diamond that we know of on Earth, a smooth and rigid shell wrapped tightly all the way around the far stranger matter deep within. The 26th fact is that the crust of a neutron star is thought to be perhaps the very strongest material in the entire universe, billions of times stronger even than the toughest metals ever forged on Earth, able to quietly withstand the crushing and endless weight of the whole star pressing down upon it forever, never yielding, never breaking. The 27th fact is that as you sink deeper and deeper into the crust, the atomic nuclei grow steadily heavier and more crowded together, richer and richer in neutrons all the while, until at last they can hold no more, and the extra neutrons begin to gently drip and leak out from the nuclei themselves. The 28th fact is that this gentle escape of neutrons is quietly called neutron drip, and it marks the soft boundary where the outer crust gives way to the inner crust, a hidden place where free neutrons begin to flow among the crowded nuclei rather like a strange, still, and utterly silent underground sea, flowing freely where no such sea could ever be on Earth. The 29th fact is that deep within the inner crust, the crowded nuclei may be squeezed and pressed into strange and unexpectedly beautiful shapes, stretched out into long tubes and flattened into wide sheets that physicists have gently and playfully named nuclear pasta, spaghetti, and lasagna, all hidden far below in the crushing and endless dark. The 30th fact is that beneath the crust lies the outer core, where matter dissolves entirely into a smooth and uniform fluid of neutrons, mixed with only a small number of protons and electrons, flowing freely and quietly in a way that no ordinary liquid found anywhere on Earth could ever truly hope to match, smooth and strange and utterly unlike our world. The 31st fact is that the neutrons in this deep and hidden fluid are thought to become a superfluid, a remarkable and delicate state of matter that flows entirely without any friction at all, swirling on and on forever once it is set in motion, calm and frictionless and untroubled in the endless dark within. The 32nd fact is that the protons deep inside the core are believed to become a superconductor, carrying their electric currents without any resistance whatsoever, so that within a single quiet neutron star lie some of the strangest, coldest, and most delicate quantum states known to exist anywhere at all in the whole of nature, quiet wonders hidden deep within the dark. The 33rd fact is that what lies at the very center, in the innermost heart of the core, remains one of the deepest and gentlest mysteries in all of physics, for the matter squeezed together there is pressed far beyond anything we could ever recreate or carefully study in any laboratory here on our own Earth. The 34th fact is that some scientists quietly suspect that in the very deepest core, the neutrons themselves may be crushed so far that they dissolve into their smallest parts, a strange and flowing soup of free quarks, forming what is gently called strange or quark matter, hidden forever and softly from all of our view, a possibility we can only gently imagine tonight. The 35th fact is that because we simply cannot ever see inside them directly, astronomers study neutron stars by very carefully measuring their size and their mass and the faint light they send us, slowly narrowing down which exotic kinds of matter could possibly exist within their quiet, hidden, and deeply mysterious hearts. The 36th fact is that a neutron star's rigid crust can sometimes crack and shift quite suddenly, in an event rather like an earthquake here on Earth, though we gently call it, instead, a starquake, releasing a quiet pulse of energy as the crust settles softly into a very slightly rounder and more comfortable shape, easing the great strain that had slowly built within. The 37th fact is that these starquakes are thought to cause tiny, sudden little changes in how fast some neutron stars spin, gentle small hiccups in their otherwise steady turning that astronomers can measure with truly remarkable precision, quietly reading the hidden inner life of the crust from very far away across the silent dark. The 38th fact is that despite holding the entire mass of a whole sun, a neutron star is so very small that its complete surface would fit easily within a single quiet city, and you could, in principle at least, drive slowly all the way across the whole of it in less than half an hour, so small and yet so impossibly heavy at once. The 39th fact is that the surface gravity is so utterly immense that if you could somehow stand upon a neutron star, you would be flattened instantly into a thin and silent film, and even a small pebble dropped from a modest height would strike the surface far faster than any bullet ever fired here on Earth. The 40th fact is that seen gently from very far away, a neutron star is simply a small, warm point of light in the dark, turning quietly and faithfully, harming nothing whatsoever. A calm and distant beacon holding within it some of the most extreme and beautiful physics that the whole universe has ever quietly made, turning faithfully far beyond our reach and our worry. The 41st fact is that many neutron stars spin very rapidly and send out narrow beams of light from their magnetic poles, sweeping around and around across space rather like the turning beam of a lighthouse. And when one of those beams happens to sweep across the Earth, we call that particular neutron star a pulsar. The 42nd fact is that a pulsar seems to pulse, to blink softly on and off with astonishing regularity. But the star itself is not truly flickering at all. It is simply turning, and we only see its beam in the brief and repeated moments when it sweeps gently past our own small and distant world, a light passing by and then gone again. The 43rd fact is that the very first pulsar was discovered in the year 1967 by a young graduate student named Jocelyn Bell, who patiently noticed a strange and remarkably steady ticking signal buried in her data, repeating so very precisely that it seemed, at first, almost impossible for nature all on its own to make. The 44th fact is that so regular and so precise was that first pulsing signal that the astronomers half-jokingly labeled it little green men, wondering for just a brief and quiet moment whether they might somehow have stumbled by chance upon a gentle message being sent to them from some distant and unknown world, though the truth would prove stranger and lovelier still. The 45th fact is that very soon afterward, however, more of these steady ticking signals were found scattered across the sky, and astronomers gently realized that they had discovered not distant messengers at all, but a wholly new kind of star, the spinning neutron star, found real at last after decades of being only an idea. The 46th fact is that pulsars are among the most precise natural clocks in the entire universe, keeping careful time with their steady pulses so faithfully and so reliably that some of them rival the very finest atomic clocks ever built by human hands, ticking on quietly and patiently for millions upon millions of years, faithful and steady long after we are gone. The 47th fact is that the fastest known pulsars spin astonishingly quickly, turning many hundreds of times over in every single second, so that their surfaces race around at a large and dizzying fraction of the speed of light itself, and yet they hold perfectly together, calm and whole, against all of that furious motion. The 48th fact is that the very fastest known pulsar spins about 716 times in every single second, far faster even than the whirling blades of a kitchen blender. A whole sun's worth of dense matter turning around so incredibly quickly that the human mind can scarcely begin to picture it at all, a blur of motion held together against all odds. The 49th fact is that these extraordinarily fast pulsars are gently called millisecond pulsars, because they complete each full and graceful turn in only a few small thousandths of a single second, spinning so very smoothly and so steadily that their faithful timekeeping can quietly rival the very best and most careful clocks on Earth. The 50th fact is that millisecond pulsars are thought to have been gently spun up to such tremendous speeds by a nearby companion star, slowly drawing gas and spin away from their patient neighbor over very long ages, until they turned faster and faster still, in a quiet, gradual, and truly ancient cosmic recycling, the slow gift of one star given to another. The 51st fact is that the beams of a pulsar stream out from its magnetic poles, and because those magnetic poles are usually tilted somewhat away from the spin axis, the beams sweep around and around as the star turns, much like a lighthouse whose bright lamp is set at a gentle angle to its turning. The 52nd fact is that as a pulsar slowly ages, it very gradually loses energy and spins down, turning just a little more slowly with each passing age, so that the very oldest pulsars pulse the most slowly of all, their once furious and youthful spin gently winding down over many millions of quiet years, like a great and patient clock at last running slow. The 53rd fact is that by very carefully measuring how quickly a pulsar is slowing down over time, astronomers can gently estimate its age, its magnetic strength, and the energy it is quietly pouring outward into space, patiently reading its whole long life story from the faithful and unwavering rhythm of its steady pulses. The 54th fact is that some pulsars send out beams not only of radio waves, but also of visible light, of energetic X-rays, and even of very powerful gamma rays, glowing softly across many different kinds of light all at once as their narrow beams sweep steadily and faithfully around the slowly turning sky, painting the darkness in many kinds of quiet light. The 55th fact is that in the year 1974, two astronomers discovered a remarkable pair of neutron stars orbiting one another, and by patiently watching their orbits slowly shrink over the following years, they found the first quiet evidence that gravitational waves are truly real, a discovery later honored with the Nobel Prize in Physics. The 56th fact is that pulsars have even been used as cosmic lighthouses to help with navigation, and a small map showing the position of the Earth relative to 14 chosen pulsars was carefully engraved upon the Pioneer and Voyager spacecraft. A gentle message left quietly drifting outward for whoever might one distant day find it, a soft signpost among the silent stars. The 57th fact is that astronomers now patiently watch great arrays of the most stable millisecond pulsars all across the whole sky, using their faithful ticking to search for the faint ripples of gravitational waves washing very slowly through our galaxy, listening to the whole vast cosmos through these tiny, steady, and distant natural clocks. The 58th fact is that a pulsar's beam is not at all guaranteed to point our way, and so for every single pulsar that we can actually see, there are surely very many more neutron stars whose beams simply never sweep across the Earth at all, turning quietly and unseen, forever hidden from our watching eyes, alone in a darkness we will never behold. The 59th fact is that the energy that lights a pulsar's bright beams is drawn entirely from its own spin, so that with each and every pulse it quietly gives away the tiniest whisper of its turning, gradually trading its motion for light across the long and patient ages, glowing ever more softly as it slows. The 60th fact is that some pulsars sit at the very heart of the glowing clouds left behind by the supernova that first made them, and the young pulsar resting within the Crab Nebula, born from a star that people saw explode in the year 1054, still gently lights that beautiful nebula even now. The 61st fact is that every single neutron star carries a magnetic field of truly staggering strength, for the collapse of the original star concentrates its own magnetic field down into a tiny space, making neutron stars by far the most powerfully magnetic objects known to exist anywhere at all in the whole of the universe. The 62nd fact is that a typical neutron star has a magnetic field perhaps 1 trillion times stronger than the Earth's own gentle and familiar field, strong enough to completely reshape the very atoms sitting at its surface, quietly stretching them into thin, strange needles all aligned neatly along its powerful and invisible lines of force. The 63rd fact is that among these already deeply magnetic stars, there is a rare and truly extreme kind called a magnetar, whose magnetic field is stronger still, perhaps a full 1,000 times mightier even than that of an ordinary neutron star, making them the very most magnetic objects that we have ever managed to find. The 64th fact is that a magnetar's magnetic field is so utterly immense that if one ever drifted as close to us as our own moon, it could quietly and instantly wipe the data clean from every credit card and every single computer across the whole of the Earth, from that great and silent distance away. The 65th fact is that if you could somehow approach to within 1,000 kilometers of a magnetar, its overwhelming field would be strong enough to gently pull apart the very atoms of your own body, quietly dissolving matter itself. So deeply and profoundly extreme is the magnetism that is woven all through the space around it. The 66th fact is that magnetars are really quite rare, and only a few dozen of them are known within our whole galaxy, for their intense magnetic fields tend to decay away over just a few thousand years, so that we see them only very briefly, during the youthful and restless early part of their long lives. The 67th fact is that the tremendous magnetic field of a magnetar places enormous stress upon its rigid crust, and every now and then that crust suddenly cracks and shifts, releasing a great burst of energy in a single violent event that can briefly outshine, for one bright instant, as much as 1,000 ordinary suns. The 68th fact is that in the year 2004, a single giant flare from a distant magnetar on the far side of our own galaxy briefly disturbed the Earth's upper atmosphere. Even though that magnetar lay some 50,000 light-years away, a faint whisper of its power reaching quietly across the immense and silent dark. The 69th fact is that that distant flare, in only a small fraction of a single second, released far more energy than our own sun pours out across a full 100,000 years of shining, and yet from so very far away it caused our small world no harm at all, only a gentle and passing flicker. The 70th fact is that magnetars are the source of strange, brief bursts of gamma rays and X-rays that astronomers quietly call soft gamma repeaters. Sudden little flickers of high-energy light that flare up and then softly fade away again as the magnetar's mighty field slowly twists and settles restlessly within itself over time. The 71st fact is that the magnetic field of a magnetar is so incredibly strong that it actually changes the very nature of the empty space all around it, bending passing light in strange and unfamiliar ways and reshaping the vacuum itself, in subtle effects that only such extreme places in the whole cosmos can ever reveal to us. The 72nd fact is that some scientists now believe that magnetars may be quietly responsible for at least a few of the mysterious fast radio bursts, those brief and brilliant flashes of radio light that arrive suddenly from very far across the universe, each one lasting only a single small thousandth of 1 second before it fades. The 73rd fact is that in the year 2020, a fast radio burst was traced, for the very first time in history, to a magnetar living within our own Milky Way galaxy, gently confirming that these restless, deeply magnetic stars can indeed be the true source of at least some of those distant and fleeting flashes of light. The 74th fact is that neutron stars, whether quiet and steady pulsars or restless and flaring magnetars, are all alike the collapsed hearts of great stars that died very long ago, and the differences between them come chiefly from how fast they happen to spin and how powerful the magnetic fields are that they carry through the dark. The 75th fact is that the magnetic poles of a neutron star may lie quite far away from its spinning poles, and this gentle tilt is exactly what carves out the sweeping beams and drives much of the star's restless behavior, quietly shaping how it glows and softly flickers to us as it turns around in the dark. The 76th fact is that some neutron stars quietly pull streams of gas away from a nearby companion star, and as all that gas spirals slowly down onto the surface, it heats up and glows brightly in X-rays, so that the pair together shine as what astronomers gently call an X-ray binary, glowing faintly in the dark. The 77th fact is that when enough gas gradually gathers upon such a neutron star's surface, it can suddenly ignite in a fierce thermonuclear flash, a brief and brilliant burst of X-rays flaring outward, before the star grows calm and quiet once more, and patiently begins to gather up the very next gentle layer of gas. The 78th fact is that the immense gravity of a neutron star strongly bends the light rising up from its own surface, so much so that we can actually see a little more than half of the whole sphere all at once, as the far side is gently curved up into view around the edges by gravity itself. The 79th fact is that neutron stars slowly cool over many millions and even billions of years, fading gradually from their brilliant, glowing youth into a quiet and dim old age, until at very last they grow far too cold and too faint to see, drifting on invisibly through the dark, still holding a whole sun within. The 80th fact is that for all of their violence and their many extremes, neutron stars actually spend most of their very long lives in perfect calm and quiet, turning steadily on in the dark, cooling ever so slowly, harming nothing at all whatsoever, simply keeping their ancient and faithful rhythm through age after age after age. The 81st fact is that sometimes two neutron stars are born together, orbiting one another, and over many millions upon millions of years they slowly spiral inward toward each other, drawing closer and closer all the while, in a long and graceful and unhurried dance that must, at the very last, end in their gentle joining. The 82nd fact is that as two neutron stars slowly spiral together, they gently stir the very fabric of space itself, sending out faint ripples called gravitational waves, tiny trembling waves that spread outward across the whole universe at the speed of light, quietly carrying away the energy of their long, slow, and patient dance. The 83rd fact is that in the very final moments of that long dance, the two neutron stars whirl around one another hundreds of times in every single second, and then at last they merge fully together, in a brilliant and violent flash of light that lights up the surrounding darkness for one brief and glorious instant. The 84th fact is that in the year 2017, for the very first time in all of human history, scientists here on Earth managed to detect the gravitational waves from two distant neutron stars merging together, faint ripples that had traveled for 130 million years across the dark before arriving gently here at last. The 85th fact is that that very same neutron star merger was also seen directly as a flash of light, watched carefully by telescopes all across the whole world, marking the first time in all of history that a single cosmic event was witnessed both in gravitational waves and in ordinary, familiar light together side by side. The 86th fact is that when two neutron stars merge, the violent collision forges vast quantities of the heaviest chemical elements, and much of the gold and platinum found anywhere in the universe, perhaps even the very gold in a ring resting upon your own hand tonight, was very likely made in such an ancient meeting. The 87th fact is that the glowing cloud thrown gently outward by a neutron star merger is quietly called a kilonova, a soft and slowly fading light that shines on for a few short days or weeks as the freshly made heavy elements within it gently cool and drift outward into the surrounding, waiting dark. The 88th fact is that this means the very atoms of silver and gold that adorn and brighten our world were not truly made in ordinary stars at all, but were instead forged in the fierce and beautiful collisions of neutron stars, long, long ages ago, and then scattered gently outward across the young galaxy. The 89th fact is that a neutron star merger may leave behind an even larger neutron star, or else, if the combined mass is great enough, it may collapse the very moment it forms directly into a black hole, in the quiet and sudden and rather beautiful birth of a wholly new kind of gentle darkness. The 90th fact is that by very carefully timing exactly when the gravitational waves and the light from that famous merger arrive together, scientists confirmed that gravity travels at precisely the speed of light, a gentle and deeply beautiful agreement with what Albert Einstein himself had quietly predicted a full century before it was ever seen. The 91st fact is that neutron stars are, in a very real and gentle sense, the true ancestors of much that we hold dear, for the heavy elements that they scatter across space slowly become part of new stars, new worlds, and, in the long and patient fullness of time, part of living things as well. The 92nd fact is that the very calcium resting within your bones, and the iron flowing quietly within your blood, were all forged long ago inside ancient stars and then scattered outward by their deaths, so that you carry within you the quiet inheritance of long-vanished suns, woven gently into the fabric of your own sleeping body. The 93rd fact is that neutron stars gently remind us of how deeply creative the universe truly is, taking the violent death of a great star and quietly folding it into something new and strange and beautiful, a small dense wonder that then helps, in its turn, to seed and enrich the many worlds still yet to come. The 94th fact is that to think carefully of a neutron star is to hold within the mind a single object of almost impossible extremes, and yet it simply turns out there, calm and steady in the dark, faithfully obeying simple and elegant laws, a quiet and gentle proof of how orderly the whole cosmos truly is. The 95th fact is that somewhere out in the deep and endless dark, at this very moment while you rest, countless neutron stars are turning slowly and silently along, sending their faint beams sweeping steadily across the void, patiently keeping their ancient rhythm exactly as they have for long ages, and will for long ages more to come. The 96th fact is that each new discovery about neutron stars tends only to deepen the mystery rather than to end it, leaving us always with a gentle, open, and endless sense of wonder at the great cosmos. A quiet wonder that asks nothing at all of us, and that soothes rather than troubles the resting mind. The 97th fact is that to quietly contemplate a neutron star is to stand ever so softly at the very edge of the possible, in a place where matter itself is pressed far beyond all of our ordinary understanding, and where simple wonder becomes a kind of deep and gentle and peaceful rest for the tired mind. The 98th fact is that as the night grows deeper and softer all around you now, you may let these small and distant suns turn slowly within your quiet thoughts, spinning gently in the dark, harming nothing, asking nothing at all, simply keeping their calm and ancient rhythm far beyond the reach of any worry or care. The 99th fact is that you are a small and gentle and deeply beloved part of this very same vast and turning universe, cradled safely upon a quiet blue world, made in truth of the scattered gifts of ancient stars, held gently in the patient arms of the cosmos, exactly and always where you are meant to be. The 100th fact is that as you drift now into sleep, the neutron stars go on turning, and the galaxies go on shining, and the whole universe goes on unfolding, patient and calm and endless, holding you softly and safely through all the quiet hours of the night. Rest now, sleep well, and thank you for drifting with me beyond the stars.